Topics covered in Chapter Determinants. Welcome to our study of determinants. In this chapter, we will follow a structured roadmap to master this essential mathematical topic. We will begin with the fundamental concept of determinants, focusing on their definition and the step-by-step process of calculating them for matrices of various orders. From there, we will explore their geometric applications, specifically how to use determinants to calculate the area of a triangle when its vertex coordinates are known. To prepare for more advanced operations, we will study the structural components of matrices, namely minors and cofactors, which serve as the essential building blocks for our work. We will then progress to matrix manipulation, learning the precise procedures to find the adjoint and the inverse of a square matrix. Finally, we will move into practical implementation, applying everything we have learned to solve systems of linear equations using methods such as Cramer's rule and the matrix inverse method. Once we have established this mathematical foundation, we will transition to exploring how these concepts are applied in the real world, ranging from physics and engineering to computer graphics and cryptography. Real-world applications of determinants. Now that we have outlined the specific mathematical tools and procedures we will be mastering in this chapter, you might be wondering, where do these calculations actually apply in the real world? Let's look at some fascinating applications. First, in the fields of physics and engineering, determinants are indispensable. They are used to calculate cross products, determine the torque of a force, and are even used by civil engineers to analyze the structural stability of buildings and bridges. If you are interested in computer graphics, such as 3D rendering or game development, you are already interacting with determinants. They are essential for performing coordinate transformations, which allow developers to scale, rotate, and shear objects within a digital space. Moving into the realm of economics, professionals employ determinants to solve complex input-output models and to analyze equilibrium states within various market systems. Finally, in the world of cryptography, determinants play a vital role in digital security. The process of encoding and decoding secure messages often relies on matrix inversions, a process that is fundamentally dependent on the value of the determinant. As we move into our first topic, keep these practical uses in mind, as they demonstrate the true power of the concepts we are about to study.